Okay, this video we're going to look at finding the inverse of exponential functions. And I'll have a video on finding the inverse of logarithmic functions also. And then I already have a video up on finding the inverse of just regular functions. Okay, rational functions, square roots, that kind of stuff. All right, so, and you can check those out. All right, so here to find the inverse, we're going to use this switch and solve method. Some books call it this, some books might call it something else, but it's basically the same thing. Um, so the first thing we're going to do is we're going to change f of x to y, and then we interchange the x's and y's. We swap the x's and y's, and then after you swap them, you solve for y, and then once you solve for y, you change the y to the f inverse symbol. Okay, so I've got 4 examples to work, so you might want to watch all of them. They're all a little bit different. All right, so let's get started. So here we have f of x equals 2 raised to the x power. All right, so remember the first step, it says change f of x to y. So I get y equals 2 to the x. Then we interchange the x and y. So wherever there's a y, the y becomes a x, and all the x's, they become a y. Okay. Now I need to solve for y. Well, how do I do this? Well, there's a couple of ways we can do it, but let me show you. Do you remember if you have, say, this formula y equals the log of x with base b? If we convert this to exponential form, that's b to the y equals x. Okay. Well, so what we're going to do is we're going to take this exponential form and we're going to convert it to logarithmic form. All right. So you see the exponent, in the formula? That's over here on this side of the equal sign. So that's y equals, okay. All right, so look at this. You see the base of the exponent? That's the base of the log. So that equals the log. The base of the exponent is the base of the log. And then this term over here, see the x? That's what we're taking the log of. Okay. Now, you know, I know you may not have gotten to logarithms just yet, but this is the property we use to convert it. Okay. Now, you should know how to, well, I guess you should know how to do this if you're on finding the inverse of exponentials. So, but anyway, there it is. All right, and so now we solve for y, and now what does it say? Change the y to the f inverse symbol. So that's log x base 2, and there's our inverse. All right, let's look at another one. Example 2. All right, so first thing, we're going to change the f of x to y. So that's 5 to the 2x minus 1. Okay. Then we interchange the x's and y's. So I get x equals 5 to the 2y minus 1. Okay. And then we solve for y. So once again, we're going to convert this to logarithmic form. So remember the exponent, that comes over here. So 2y minus 1 equals the log. And remember, the base of the exponent is the base of the log. And then the x goes here. But remember, we need to solve for y. So here, I'm going to need to add 1 to both sides. So I get 2y equals the log of x with base 5 plus 1. And then we'll divide both sides by 2. And so I get y equals the log of x with base 5 plus 1, all that over 2. So we've solved for y. So I take the y and I change it to the f inverse symbol, and I get log x base 5 plus 1 over 2. And that is my inverse. All right, we got 2 more to go. All right, let's look at this one. So first thing, change the f of x to y. So I get y equals 3 to the 2x plus 5 over 7. Okay. Swap the x's and y's. So I get x equals 3 to the 2y plus 5 over 7. And then what did we do? Well, we solved for y. But what was the first step we did? We would just go ahead and convert it to logarithmic form, wouldn't we? But if you notice in the other problems, we didn't have that. We didn't have it being over a number or something like that. Okay, well, we can't convert it with this being over 7. So what we need to do is bring the 7 to the other side. So, that's over 1. It's kind of like we're cross multiplying. So that's 7x equals 3 to the 2y plus 5. Now we can convert it to logarithmic form. So remember, there's our exponent. So that's going to be 2y plus 5 equals log of this 7x with base 3. And then I solve for y. So I'll subtract 5 to both sides. So I get 2y equals log 7x base 3 minus 5. And then I divide everything by 2. And so I get y equals log 7x base 3 minus 5, all that over 2. And then we change the y to the f inverse symbol. I'm not going to rewrite it again. I'm just going to erase the y and change it to the f inverse symbol. Okay, save a little bit of time. All right, so here's the last one. All right, so f of x equals e raised to the 3x plus 5. All right, so take the f of x, change it to y, so that's e to the 3x plus 5. Swap the x's and y's, so that's going to be x equals e to the 3y plus 5. And then I solve for y. So let's convert it to logarithmic form. So that's 3y plus 5 equals, and then that's going to be the log base e of x. Okay. Now we solve for y. So I'm going to subtract 5. And so that gives me 3y equals, now look at this. We've got log of x with base e. Do you remember when you're dealing with logarithms, log base e is what? Let me write that a little better. Is natural log. Remember that? So I'm going to rewrite this log x base e as natural log x minus 5. And then we'll divide both sides by 3. And so that's going to give me y equals natural log x minus 5 over 3. And then of course, you can rewrite it. You got to change the y to f inverse. And there's your inverse. Alright, so I hope this video helped. Like I said, check out my other videos on the inverse functions. I got one just normal functions. Then I've got this one, the exponential functions, and then I've got another one, inverse of logarithmic functions. So check those out. Hope this helped. Give me a like, subscribe, share the video. Thanks for watching.